my name is Adam. I'm a PhD student at the University of Auckland in New Zealand. And as part of my PhD project, I've been developing an R package for interactive data visualization. And I thought about making this video so that I could show you what the package is about and how you can use it to explore your data. And if you do decide to try out the package and you find there are some things that work for you or others that don't, or you have some suggestions, then I would love to hear from you because if I can integrate your feedback, make the package better, that's it's a win-win for everyone, I think. Anyway, if you want to install my package, it's currently not on CRAN yet. However, it will be soon, and for the time being, you can install it using the DevTools install GitHub function. So just call the function and you pass it the name of the repo, which is bar20check/plotscaper. But don't worry about installing it right now. At the end of the video, I will also have a link to my package repo, and all of the relevant instructions are there. So once you have the package installed, you can load it in like any other library, and then we need some data to explore. And there's one package that I particularly like in the one dataset that I particularly like in the carrot package, and that's because it's got a nice mix of variables that I can use to show off the different features. So anyway, to load in this dataset, we use the data function, and the dataset is called Sacramento. So we can just load it in like so, and then if we have a look, we'll see that the dataset contains a bunch of variables related to the sale of houses in the wider Sacramento area. And so there's variables like the house's latitude, longitude, the price the house was sold for, the number of beds, baths, the city it was in, and so on. And there's almost 1,000 houses here. So to start exploring the dataset with plotscaper, we can call this create schema function and pass it the dataset. And what this function will do is that it will sort of set up like a recipe that we can use to define our figure. And once we have that, we can start adding plots. So for example, I could first add a scatter plot of the house's longitude versus its latitude. And since this is a geographic coordinate, we probably want to make sure that the aspect ratio is set to 1. So I can do that here by passing this argument. And then we can add other plots. So for example, I can add a bar plot of the city where the house was in. I can add a fluctuation diagram of the number of beds against the number of baths. And for good measure, let's add a histogram of the square footage. Right. And so now we essentially have everything. The one more thing to do is we need to call this render function. And this actually takes the recipe and turns it into a figure that will be showed in the viewer. And this is perhaps slightly different to what you're used to from, let's say, ggplot2, where if you print the plot specification, it automatically renders. And there's a good reason for why there's a special function here. But yeah, if you want to learn about that, then you can go read some of the package vignettes. Anyway, if we run this, it's going to set up the figure, and as you can see, it's got all of the plots that we defined here. So it's got the scatter plot, the bar plot, the fluctuation diagram, and the histogram. And this is an interactive figure, so we can do some, first some like boring things, like we can resize the figure and see that it will automatically, resize the plots. And notice that, for example, the scatter plot, it actually respects the aspect ratio. So the aspect ratio of the two axes is still the same. And then we can do some other things. So we can do, like your usual, we can do panning, and this works for all types of plots. we can also do zooming. So to do zooming, we need to use the left mouse key to select the rectangular region in one plot, and then we press the Z key, and it's going to zoom into that region. And anytime you do any of this interaction, you can always restore the default state by pressing the R key. So I'll do that, and we're back to sort of where we started. And what I didn't mention with the panning is, for panning you press the right mouse key. So yeah, just that. And now you might have noticed while I was zooming in the plot that if I click and drag to create a rectangular region, then the points in the region in the scatter plot get darker, and they also get sort of highlighted across all the other plots, the corresponding cases. And this is because all of the plots in plotscaper are linked by default, so you can do what's called link selection. It's like where you select some cases and they get highlighted everywhere else. And by default, this does what's called transient link selection. So if I first select some cases and I click somewhere else in the plot, the selection disappears. Or if I highlight, then click on another plot, click again, the selection goes away. But I can actually make the selection permanent by pressing the either 1, 2, or 3 key while I'm doing the selection. And then this will actually assign the selected cases to like a permanent group that will sort of stay selected even if I click away. So now if I click to a different plot, and I can still do the transient selection as well, so I can actually combine the two different levels of selection. But if I click away, only the transient selection disappears. And so there are, a couple of different commands you can do with either your mouse or your keyboard. So to see the different keyboard commands, there's this button in the top right here. So if you ever if you're ever lost about what different keys you can use, you can have a look here. And you can also remap the keys. So if you find that some of the keys doesn't work for you, you can click here and then use whatever key on your keyboard you want. So those are some basic types of interactions in our plots. To get rid of the permanent selection, you double click. So that's also documented in the vignettes. Yeah, sorry. Anyway, there's also other types of interactions we can do. So we can, for example, increase or decrease the histogram bin width by pressing the plus or minus key. And we can do the similar thing for the histogram anchor. So for that, it's the semicolon or quotation mark key. So we can sort of shift from where the histogram bins start. And like the other sort of interaction types, this can be reset with the R key. And then also for some plot types, we can what's called normalize them. So for example, if say I select some cases here in the scatter plot, and I'm interested to, let's say, know what proportion of the cases in each city these green points make up, then it's quite hard to read it from the regular bar plot. But what I can do is I can press the N key, and this will turn it into a spline plot, which actually shows the proportion of cases on the y-axis. And the width of the bar now corresponds to the count. So for example, I can see that there really isn't that many cases here from the Sacramento, and that's actually because the Sacramento region is sort of more here. So these are more like the suburbs of the city. And and you can do this with the bar plot. You can also do this with histogram to turn it into a spinogram. And you can also do this with fluctuation diagram and several other types of plots. So that's normalizing plots. with bar plot, we can also reorder the bars. So if I press the O key, it will sort the bars by the number of cases. And now if I, if I select some cases, they will be within the corresponding bars. And yeah, and there's bunch of other types of interactions. Some of the interactions you can actually do from inside the running R session, which actually that becomes slightly more complicated. So I can actually show how to do it. It's just that for that we need to actually get a handle for the interactive figure. So what I've done here is I've just run a command that has rendered the figure, but I don't have any way to refer to the figure. So what I can do is I can first save the schema into variable, and then I can create another variable which will be just me rendering the schema, and I'll call this scene. It's scene. Yeah. And if I render this, I get back the same thing. However, I can call code from R to modify the scene. So for example, I could, I could add another, for example, scatter plot here. Say a scatter plot of the square feet and the price. And what will happen is that I'll add the plot into the figure, but notice that when I did that, the figure didn't re-render. So I'm actually communicating directly with the figure. I'm not re-rendering the whole thing. And actually, if I do this multiple times, it's going to keep adding plots. To also, to be able to go the other way around, I can also remove plots. So there's a pop plot function which just removes the last plot that I've added. And if I sort of get into the number of plots where it's the sort of where it sort of the figure should resize, then it will do that automatically. And I can also do other things. So I could, for example, whereas before I had to use my mouse to select specific cases of the data, I can also select them by running a function. So I can call select cases. Let's say I want to see the first 100 houses. It will show them to me like this. And this is already something that that's where it becomes important to highlight the difference between the scene and the schema. So for example, I can use most of the same functions here in the schema. So for example, I could say here select cases 1 to 100, and now each time I render the scene, those selected cases are going to be there because selecting the cases is now part of the recipe. Whereas if I let's say I'll select the other 100 cases. If I do this now with the scene, then if I re-render the scene, that interaction is just going to go away. So sort of I need to be mindful about the way in which I do things. You can basically, for most of the interaction, you can either do it with the scene or with the schema. It doesn't really matter. If you do it with the schema, you always have the right state that you can go back to, right? So you can always sort of reset. Whereas if you do something with the scene, then it's in some way it's more interactive, but you might run into a problem where you might get into some state which you can't really recover again. So that's just something to think about. I've written a vignette about that, so you can read that if you want. And so there's a bunch of other interactions you can do. You could, for example, you could set scale of a specific plot. So for example, if I want to set the scale of the scatter plot, I need to give it an identifier, which here I could use plot 1. I could also say scatter 1, which will be the first scatter plot that's in the scene sort of going from the top left to the bottom right. And then let's say I want the minimum to be minus 122. So if I do that, oh right, I didn't specify the axis that I want to set the scale of. So I'll specify the x-axis, and now it's going to move my plots around. And in the same way that before we did the zooming manually, I can also zoom. So for example, if I wanted to zoom into the middle 50% of my plots, I could say, so first I need to specify which plot I'm zooming into. So let's say again the scatter plot, and to zoom into the middle 50%, I can specify that I want sort of the sort of normalized limits to be here 0.25, 0.25, or 0.75, 0.75. So if I run this, we see that we've zoomed in into the, it's kind of like if you take the whole plot and you make a rectangle in the middle, that's 50% of the width and 50% of the height. That's what we basically did just now. Yeah, so there's a bunch of other interactions you can do. I'm not going to go over all of them, but if you're interested, go read the vignettes that I'll sort of give a link to at the end of the talk, and or at the end of the video. And one more thing that I wanted to show off is that the package is actually pretty good in terms of performance for sort of moderately sized datasets. Actually this is, yeah. If we want to stress test the package, one dataset that's sort of popular is the diamonds dataset from the ggplot2 package. So I can just load it in like so. And if we have a look, it is a data set of 50,000 cases of diamonds, and it's got variables like the carat, the price of the diamond, the color, things like that. So let's make an interactive figure of the dataset. So again, I'll run the create schema function. I'll add a scatter plot of the carat and the price, and I'll add a bar plot of color, and let's just leave it at that for now. So now I'm going to render it, and this is going to take a little bit of time because we are rendering 50,000 data points, and there are also some additional things going on, like the plot is automatically resizing the margins and things like that. So it sometimes takes a bit of time for the first time render. But now we have the whole data set here visualized in a scatter plot, and we can see that there's really quite a lot of data points. I mean, this is not like someone would say big data per se, but I think 50,000 data points for interactive visualization is not too bad. And we can still do the usual interactions that we've done before. So we can do selection, panning, zooming. And I mean, the interactions do get a little slow for a data set of this size. But one thing particularly is that there seems to be a bit of a slowdown in the RStudio viewer as well that I just haven't been able to figure out. But if we open the figure up in the browser, it's actually a lot better. So let me just open it up. So again, now the initial render takes a little bit of time, but Now we have the figure. And now if you have a look, the interaction is actually much smoother. So now we're brushing all 50,000 data points, and we can see, so for example, here we can compare the different trends in how the price of the diamonds grows the carats. So for example, we see as we get sort of into these later colors, the price actually grows slower with the number of carats. So this color D, for example, seems like the sort of the most desirable diamonds color, I guess. I'm not a diamonds expert, but I'm just making up a story here. Anyway, yeah, thank you very much for watching, and I hope that you might find the package useful for your data exploration. And if you have any feedback, you know, again, like I said, if you try it out, you see that there are some things that work for you, some things that don't, then that's exactly what I'm looking for. Like, I really want to make this a good package for data exploration. So if you find some problem, find some bugs, then let me know, and I'd love to hear from you. So happy data exploration. Hi again. So I actually realized I forgot to link to my package repo at the end of the last video. So I'm just going to do that now. So the repo is /plotscaper. If you scroll down here, there's a bit of a readme with general information about the package. Here's how you can install the package. And then more importantly, up here, there's a link to the package website. And if you go there, it's got you know, a bunch of vignettes. You have the getting started vignette, which actually has live versions of the figures, so you can do all of the, you know, all the stuff that I was showing off in the video in RStudio. You can actually do it here on the website. And it's got some more sort of explanation of the concepts that I was talking about. And there are a couple more vignettes there. There's also the function reference. And so, yeah, so this might be quite a good resource if you want to try out the package. And yeah, that's everything from me. Yeah, thank you for watching.